step-by-step solution for question 1, which is motion, power, and energy. We will be looking at the February 2022 past exam paper. You'll first take a look at question 1. So question 1 asks, what is the basic unit of speed? So in some of these multiple choice questions, we have to note the basic SI units for the given quantities provided. And the correct answer we were looking here for is D. The basic unit of speed or velocity is meters per second. A motorcycle accelerates from rest at 4 meters per second squared. What distance will it have traveled when it reaches 144 kilometers per hour? First, we will look at the given information. The first keyword we have is from rest. When an object is at rest, it means the object is not moving. Therefore, the initial velocity should be 0. So they will use the word rest or stationary. The symbol which we use to represent initial velocity is the letter U. When we see that the object is moving from rest at 4 meters per second squared, the next important one is to look at the SI unit. Any quantity that is measured in meters per second squared is acceleration, and the symbol which represents acceleration is A. The last thing that it reaches is a velocity of 144 kilometers per hour. So we should know that when an object is moving, it will have two types of velocities, an initial and a final. So usually when we see the keyword at or from, this is initial. When we see to or of, it is our final. The symbol which we use for final velocity is the letter V. Here the velocity is in kilometers per hour. As we just learned in question 1, the correct SI unit for velocity or speed is meters per second. So now we need to convert from kilometers per hour to meters per second. And to convert from kilometers per hour to meters per second, we divide by 3.6. So 144 divided by 3.6. The correct final velocity in meters per second is 40. We're trying to calculate the distance. The symbol which we are looking for is S. So what we will now have to do is go and look at our formula page and choose the correct equation of motion. And according to our formula page, the correct equation of motion that we should now be using to calculate the distance is 2as is equal to v squared minus u squared. So how we choose a formula is based on the given information. Our formula should contain the known values as well as the unknown. The formula should contain 3 known values and 1 unknown value. We will now check if we have all the given information to use the correct formula. 2as is equal to v squared minus u squared. Okay, so I have 2. A is 4, which is my acceleration. S is what I'm trying to calculate. The final velocity we now know is 40 meters per second squared, and the initial is 0. So this was the correct formula as it contains the 3 values for the given information and the 1 unknown variable. We now make S the subject of the formula because distance is what we are trying to find. So my distance now becomes 40 squared minus 0 squared over 2 times 4. Right? How did I get that as the subject of the formula? All right, I want to find S. So since I am multiplying here, all right, I need to do the opposite of multiplication, which is division, which means I would now need to divide both sides by 2a. So that is why here it is 40 squared minus 0 squared divided by 2 times 4. And 2a we said is 2 times 4, where a is your acceleration. When I input this into the calculator, I should now get my answer as the distance is equal to 200 meters. Question 1.3. Tabo stands in a train carriage. Right, so there's 2 objects. There's Tabo and a train, and they are both moving eastwards. The train suddenly brakes. So if the train suddenly brakes, that means the train is going to stop. Tabo continues to move eastwards. So we find we have 2 objects, Tabo and a train. The train stops, but Tabo continues to move eastwards. This is due to the effect of which motion? It is due to the effect of what is known as his inertia, and that is why the answer here should have been A. What is inertia? It is the tendency of an object that continues to move in a straight line at a constant speed unless a force acts on the object. So a simple example to think about inertia will be a car and a passenger in a car. When a driver applies brakes to the car, the brake will stop, but the driver will continue to move forward and he can hit onto a dashboard. This is due to the effect of inertia, which is why passengers are required to use a seat belt when they drive. He was moving at a constant velocity, and that velocity allows him to continuously move forward even though the car has stopped. 1.4. A 2 kilograms mass is suspended from a spring balance X. A 3 kilograms mass is suspended from spring balance Y. Balance X is in turn suspended from the 3 kilo mass. Ignore the weights of the two spring balances. So when we are doing the calculation, we are only taking mass for balance X and the mass for balance Y into consideration. We are not taking the weight into consideration. Okay, what are the weights of X and Y? So we're looking for the weight for the 2 kilogram mass and the weight for the 3 kilogram mass. All right, so if an object has mass, it has the force of gravity acting onto the object. So we're going to use weight is equal to mass times gravity. So 2 times 9.8, your weight 1 is 19.6. Mass number 2 is going to be the 3 kilograms mass, and the same formula, weight number 2 is mass times gravity, or m times g. 3 times 9.8 is equal to 29.4 newtons. So remember, weight is measured in newtons, weight is a force, right? We use the gravity as a constant value of 9.8. That is why the answer here is A. Question 1.5. Which form of energy is occurring when a heat energy is converted into potential energy? So there are many different forms of energies that we have. Energy is the ability of an object to do work. Here we are looking specifically at heat energy being converted into potential energy. So we need to understand what potential energy is, right? So potential energy actually occurs when an object is at a relative position above the ground due to gravity. So the relative position above the ground simply means when an object is at a height, right? So when an object is placed at a height and gravity is acting upon that height, that is when an object is going to have potential energy. So in simple terms, for an object to have potential energy, it must have a vertical distance or height above the ground. Select the best possible answer from the options listed below. 1. Steam causing movement. So when we have movement, movement can be in any plane. It can be on an inclined plane, vertical plane, horizontal plane. That is why we cannot use this. A moving vehicle driving uphill. Okay, we don't know if that uphill is vertically upwards or on an inclined plane. D. A meteorite that is falling through the atmosphere. It can be falling in any direction through the atmosphere. But C would be our correct answer, a hot air balloon rising in the air. So when a hot air balloon starts to rise, it takes off from the ground. So since the hot air balloon is taking off from the ground and rising into the air, it's gaining a height above the ground. Therefore, the correct answer here is going to be C. Question 1.6. A body moves from rest in a straight line. So we've now learned that the initial velocity of an object is going to be 0. If it's moving in a straight line, it is moving horizontally with uniform acceleration. So the acceleration is remaining the same according to the law v is equal to 3 plus 2t, where v is the final velocity in meters per second and t is in seconds. So if t is measured in seconds, that means the quantity given here is time. What is the initial velocity of the body? There are 4 options. Let's look at the given data. So usually when we are given a law, v is equal to 3 plus 2t, the law usually represents an equation of motion. So we know according to this question that the v is the final velocity and the t is the time, right? Let's look at this. So v is equal to u plus at. So if I go and look onto my formula page at the equations of motion, this formula represents v is equal to u plus at, which therefore means the initial velocity is going to be 3 meters per second. So the answer here is B. 1.7. A BMW accelerates uniformly again in a straight line at 3 meters per second squared from rest. So again, the initial velocity is 0, and we have now learned that if the SI unit is meters per second squared, that is acceleration. What will be the velocity 12 seconds after its departure? So the velocity they are asking for here is the final velocity. If you've been given initial, then the next velocity has to be the final velocity. So as we said, A is my acceleration, is 3 meters per second squared. U is the initial velocity, it is 0. And T is your time, which is 12 seconds. The symbol for time is T. So we can use the equation of motion, V is equal to U plus AT. So I substitute the initial velocity as 0. The acceleration is 3 and the time is 12 seconds. So I get the final velocity as 36 meters per second. So my answer here is option A. A is equal to 36 meters per second. 1.8. A driving pulley rotates at 3 revs per second and has a diameter of 300 centimeters. The pulley exerts a force of 2 kilonewtons at a point on its periphery. What will be the power in kilowatts? So now we are dealing with a pulley. Let's look at the given data. First, it rotates at 3 revs per second, so we are now being given the rotational frequency. The symbol which we use to represent rotational frequency is 3 revs per second. If you see the word rotates, it means we are now dealing with an object that is spinning or rotating. In other words, we are dealing with angular motion, like the wheels of a tire, right? The units of measurements for angular motion is very different from when it is moving linearly on a straight line. So that is why we are using N, which represents the rotational frequency. D is my diameter. The diameter here is 300 centimeters. The correct SI unit is meters. So I'm going to convert from centimeters to meters. And to do that, I'm going to say 300 divided by 100, which is 0.3. Next, I have a force. All right, for an object to spin or rotate at an angle, a force needs to be exerted at the center of an object. Here, the force is 2 kilonewtons. I cannot leave the force in kilonewtons. Force is measured in newtons. So I'm going to say 2 times 1,000, which is 2,000 newtons. So to convert from kilonewtons to newtons, we multiply by 1,000. The correct formula that we can now use to calculate power for a belt drive or a pulley system is P is equal to F times V, where P represents your power, F is your force, and V is your velocity. Right? I have the force, which is 2,000, but I do not have the velocity or the speed of the pulley. That is why I need to use a next equation or a formula to get the speed or velocity of a pulley or a belt drive system. And according to my formula page, that formula for V, which is the speed or velocity for a pulley or a driver belt system, is V is equal to pi dn. Okay, so we need to find the velocity when an object is rotating. Right? In the previous question, we had a velocity where it had an initial and a final velocity. Okay, in this question, the velocity is when the object is rotating in a circle. In the previous questions, it was moving on a straight line. So let's substitute. We've got the force is 2,000. Pi is a constant factor. We now have the diameter 0.3 and the rotational frequency in revs per second is 3. So I would end up with 5,654.867 watts. So when I calculate this power, it is in watts. My question says calculate the power in kilowatts. The next thing I need to do is convert from watts to kilowatts. And to convert from watts to kilowatts, I'm going to divide by 1,000. So I'm going to say 5,654.867 divided by 1,000. And I'm going to end up with the power as 5,655 kilowatts. So the correct answer here is D. Next question, a flat belt has a thickness of 0.435 centimeters. So this is now different. We are still dealing with the belt drive or a pulley system, but we now have a thickness. So when a thickness is added to the belt drive, it's going to affect the speed of the belt drive, and the belt drive is now going to have what is known as an effective diameter. All right. So remember, when a belt has a thickness, we are dealing with the effective diameter. The driver pulley of a petrol motor has a diameter of 39.5 centimeters and it rotates at 300 revs per minute. The tight set has a tension of 1.4 kilonewtons and the tension ratio is 3:1. Consider the belt thickness. So this is a very important statement. They are giving you a hint or a clue by saying consider the belt thickness. Once you see the terms consider the belt thickness, it means your calculations must involve the thickness. So somewhere in the formula, we must see thickness being added to the equation. And as we said, the thickness affects the speed of the belt as well as the power that's going to be generated. What will the value of the belt velocity be? So since we have just learned now that the thickness affects the velocity of the belt, that means when I choose a formula to calculate velocity, I need to include the thickness in that equation or the formula. So if I look at the given data, I've got the small letter t. So in this equation, t does not represent time. In the belt drive equation or the pulley equation, the small letter t represents thickness. T is 0.435 centimeters and we should have thickness in meters. So to convert from centimeters to meters, I'm going to divide by 100 and my thickness becomes 4.35 times 10 to the minus 3 meters. Right? The diameter here is 39.5 centimeters. Again, to convert from centimeters to meters, I'm going to divide by 100 and my diameter becomes 0.395 meters. Now I have the rotational frequency. All right, we said N is 300 revs per minute. We've just learned that the rotational frequency needs to be in revs per second. Why? Because time is measured in seconds. To convert from revs per minute to revs per second, I'm going to divide by 60. So the rotational frequency is now going to be 5 revs per second. T1 is the tension or the force in the tight side. So another key term or word that I can use for force is tension. Anything measured in newtons is a force. 1.4 times 1,000 is going to be 1,400 newtons. The tension ratio. So we are measuring or we are comparing the tension or the forces between the tight side and the slack side. I want to see how many times bigger is the force in the tight side compared to the slack side. When I compare it and reduce it to a ratio, I get T1 as 3 times, which is the tight side, and T2, the force, which is the slack side, as 1 times, the smaller side. The formula I'm now going to use for velocity is V is normally pi dn. But since I have a thickness and I'm using an effective diameter, the formula now becomes pi diameter plus thickness times n. So please make sure you are adding the thickness to the diameter. So the thickness is added to the diameter. So I'm going to have pi 0.395, which is my diameter, and please don't forget to add your thickness here. So I'm going to say plus 4.35 times 10 to the minus 3, and the rotational frequency in revs per second is 5. We said 300 divided by 60 is 5 revs per second. So we will now get the final velocity of the belt, which now includes the thickness, as 6.237 meters per second. So the correct answer we should have chosen here was A. A is equal to 6.273 meters per second. Thank you for watching today's lesson.